This is an exercise example of a series circuit. Well, always you have to solve an exercise with an electric circuit. The first thing you have to do is recognize which type of circuit you have to solve, series or parallel. In some more complicated cases, you can face a mixed circuit, but in this case, we have a series circuit. Why? Because we only have one way for the electrons to connect the positive pole with the negative pole. So this is a series circuit. Okay? So in all the exercises, start writing the type of circuit and the equations of this type of circuit. We have always an equation for the voltage, another for the intensity of current, and another one for the resistance. In this case, the voltage of the battery is the addition of the voltage of all the components. In this case, I have only two resistors, so only 2 volts. The current is the same in all the components in the circuit because there is only one way for the electron. So the current leaving the battery is the same current that goes this direction in the cable, the same current that is going to cross the first resistor, the same current continues this direction, and the same current that will cross the second resistor, and the same current that we go back to the negative pole of the battery. So all of them are the same. And the equivalent resistance of the circuit is the addition of the resistance of all the components in series. So this is like we have a circuit with only one battery and one resistor, and the value of this battery is the same, 9 volts, and the value of this resistance is the equivalent resistance. So this circuit and this circuit will work exactly the same, and the value of this is the addition of these two resistors. Well, once you have the equations of the circuit, in this case a series circuit, a recommendation is write a table here. In this table, we are going to insert a square for the total circuit, the voltage of the battery, the current of the battery, and the equivalent resistance of the circuit, and another square for each of the components. In this case, I have only 2 components, so I'm going to have 2 squares more. In this square, I'm going to write the voltage of the first resistance, the current, and the value of this resistance, and the same thing for the second. Okay, now I'm going to check the data that I know from the circuit to my table. I know the voltage of the battery, 9 volts. I know the value of the first resistance, 6 ohms. And the value of the second resistance, 4 ohms. The other thing I can use in all the exercises is the Ohm's law. The Ohm's law, which is this triangle, remember, is a law that I can use in all the components or in the whole circuit. So I can use the Ohm's law in this table all the time. But this is, for example, voltage is current multiplied by resistance. If I know 2 out of 3 in whatever square in the table, I can work out the third one. In this case, I only want no. In this case, I only want no out of 3. And the same thing. So I cannot use the Ohm's law at this moment, but in the future, I will use the Ohm's law. So I have to use one of the equations in this system. Okay, step by step. To use one of the equations, I must only have one unknown quantity. In this case, I know the voltage of the battery, but I don't know the voltage number 1 and voltage number 2. So I cannot use this equation. Okay, in this case, the current are the same, but I don't know any current, so I cannot use this equation. So I'm going to use this equation. Why? Because I know the resistance number 1, the resistance number 2, so I'm going to work out the equivalent resistance of the circuit. So this is going to be the beginning of my solution. The equivalent resistance of the circuit is resistor number 1 plus resistance number 2, which is 6 plus 4, 10 ohms. So these 10 ohms are the value of this circuit, this resistance, and I can take this to my table. So this is a simple circuit with one voltage, with a battery of 9 volts, only a resistor. So I can work out the current of this circuit using the Ohm's law. In this case, I can work out the current because I know 2 out of 3. So next step, Ohm's law for the total circuit, for this equivalent circuit. So the total current of the circuit is the voltage of the battery divided by the equivalent resistance, which is 9 volts divided by 10 ohms, which is 0.9 amperes. And I have used this equation. I cannot use the Ohm's law here, neither here, because I only know one of the magnitudes. So I have to continue with this equation. What happened? Once I know one current, I know all the currents in the circuit. So I'm going to use this equation. All the currents are the same, because once I know the current leaving the battery is the current crossing the first resistor at the second one. So 0.9 amps and 0.9 amps. Remember, writing the unit all the time. And just to finish, now I can work out the voltage of the first resistor and the voltage of the second using the Ohm's law, because I know 2 out of 3. So voltage number 1 is current number 1 multiplied by resistor number 1, or the same thing for the second. Voltage number 2 is current number 2 multiplied by resistor number 2, which is 0.9 multiplied by 6, 0.9 multiplied by 4. This is 5.4 volts, and this is 3.6 volts. Okay, and I have used this equation. What happened? The last of the calculations I have done, I had another opportunity, which is using the equation that I haven't used yet. I can use this equation to check if this calculation is correct. For example, if I know that the total voltage, the equation I haven't used yet, is the total voltage of the battery is equal to voltage number 1 plus voltage number 2. The total voltage is 9 volts, is 5.4 volts plus 3.6 volts. Okay, this equation is correct, so I check that my exercise is well done.